Hello, Hornets, and thank you for joining me today. Today, we're going to be starting with the basics of the unit circle. And when we talk about the basics of the unit circle, we're actually talking about three right triangles. They are the 45-45 90-degree triangle, and according to a 45-45 90-degree triangle, it is an isosceles right triangle, which means that the two legs are equivalent. We say that they are both A. The hypotenuse, which according to our trigonometry is going to be 1 unit in length, is also equal to 2a, or a root 2, excuse me. So if I have a root 2 is equal to this hypotenuse, which is the radius of the circle equaling 1. Now the reason why I'm saying the radius of the circle is because what we're talking about is a circle with a unit radius of 1 is what we call a unit circle. And so we're going to simply identify that if I have 1 equals a root 2, then I know that 1 over root 2 has to be that a value. And because we do not allow radicals in the denominator, we have to call it root 2 over 2. Now that tells me that if this right here is overlapped on my quadrant, and I'm looking at a 45-45 degree triangle, then my x is root 2 over 2 in length, and my y has a height of root 2 over 2. And this is where we get our first point on the unit circle. Then we take a look at the smaller of the two right triangles that remain, and they are the 30-degree triangle, which means that this upper part is the 60 degrees. Here is my 30 degrees. And now, according to our geometry, A is the length of that vertical. We're now talking about the hypotenuse is twice the length of A, and once again, it's the unit of 1, which is our radius of the circle, and the longer length is A root 3 from the Pythagorean theorem. Going back and finding what A is, just like we did here and found that A was root 2 over 2, root 2 over 2, which then gave me my x and my y, I'm now looking at this length being root 3 divided by 2, and this length being 1/2. That's because 1 equaling a to a, is going to give me 1/2 equaling a. And then I can just put them in to find it. That means that a smaller angle going right here on my unit circle now has a length of x that is root 3 over 2 and a height of y that is 1/2. We then go to the last of our triangles. This is the long, tall one. This is where we have the base angle of 60 degrees. So 60 degrees is here, 30 degrees is here. We're looking at, therefore, this length being A, and our hypotenuse, which is the radius of our circle with a unit of 1, is 2a, and our height is therefore a root 3. Since we have 1 equaling 2a again, we can clearly see that 1/2 is equal to a. That's now my length, and my height is root 3 over 2 when I multiply. Putting this on my unit circle, we're now going up, and we now have a height and length that we can write down, and our length is 1/2, and our height is root 3 over 2. Now you'll notice this is simply 3 values on our circle. This one, still having a radius of 1, has to be 1, 0, and going straight up with a radius of 1 has to be 0, 1. So This is the first 3 points that were 5 points that we have on our unit circle in quadrant 1. But it's important to remember that we know what our ratios are for sine and cosine. The sine ratio is the opposite over the hypotenuse. The cosine ratio is the adjacent over the hypotenuse, and the tangent ratio is the opposite over the adjacent. So when we're looking at what is the opposite and what is the adjacent, we have to recognize that we are looking at an angle that is formed by two rays. One ray going down along the bottom, and one ray at an angle. Since the hypotenuse is always the longer side, we know that the opposite side that we are looking at has to be the side that is not making up the angle. So it can't be the red or the green sides of the triangle. It has to be the purple side, or the side that is not making the 45-degree angle. That means that my opposite side of a 30-degree angle is the 1/2, and the opposite side of a 60-degree angle is √3/2. We call the adjacent side the side that is the horizontal. So this is the adjacent. So notice the adjacent is simply that same side. In each case, it's that horizontal going across. And the hypotenuse is always now opposite the right angle, and it is the longer side. So we have our opposite identified now as the side that is not forming the angle, and the adjacent is the horizontal side that does form the angle. So once again, this is our opposite, adjacent, opposite, and our adjacent. Now, because of that, when we're looking at our sine ratio, since my radius is the hypotenuse and it's 1, you'll notice that my sine is merely the y value divided by 1. And that means it's the y value. The cosine, following the same thing, is the x divided by 1, which means that it is x. And the tangent ratio is then simply y divided by x. And now we can talk about these points in the first quadrant as x and y, as opposed to opposite over hypotenuse or opposite over the radius. Not only that, but we can now go on to this and say that the cosine of 60 degrees, once again, here's my 60 degrees, and the cosine is the x value, and the x value in that point is 1/2. We can clearly see that the cosine of 45 degrees is √2/2. And the cosine of 60 degrees is √3/2. Please take note that the cosine of 90 degrees is then 0, and the cosine of 0 degrees is therefore 1. And you notice we now are starting to get our relationships for trigonometry. Let's go ahead and identify the sine. The sine of 90 degrees is going to be 1. The sine of 60 degrees is going to be root 3 over 2. The sine of 45 degrees is root 2 over 2. The sine of 60 degrees is 1/2. And the sine of 0 degrees is 0. Alrighty, so this is sine and cosine working with the unit circle and our 3 right triangles. And in the next video, we're going to be talking about how do we use the first quadrant in order to find our ratios, including how do we find our ratios for tangent. Thank you very much, Hornets. I appreciate you watching this video, and if you like it, please click like. Thank you very much. Please be well and take care, and we will continue on our next video. Bye-bye now. Be well. Cheers.